Matrices and determinants. Yeah, actually 2005 question. A square minus A plus I equal to 0. Sorry, O, not 0. Then A inverse equal to dash. First option, A. Second option, A plus I. Third option, I minus A. Fourth option, A minus I. Here, this can be written as I equal to A minus A square. A minus A square. Here A common. Here by taking A as common, we get I minus A. Remember that. Why? Because IA equal to AI equal to IA equal to A. That's why by taking A as common, generally here we are getting 1, but it is matrix equation. In matrix equation, by taking A as common, we get I. Otherwise, write down like this. A can be written as A into I minus A square. Now A common. A into I minus A equal to I. Now we have one formula. AB equal to BA equal to I. Then AB equal to I. Then A is the inverse of B and B is the inverse of A. Therefore, B inverse equal to A here. If AB equal to I, then one matrix is the inverse of the other. Of course, here you can write A inverse is also equal to B. Now here it is in the form of AB equal to I. AB equal to I. Now A inverse equal to B only. Therefore, A inverse equal to this one only. I minus A. Answer is C. Next question. Yeah, Jubilee 2004 question. A equal to 1 minus 1 1 2 1 minus 3 1 1 1. Is it over? And A inverse equal to 1 by 10 into 4 2 2 minus 5 0 alpha 1 minus 2 3, then alpha equal to x. What is alpha? Any doubt now us? Okay. Now here A inverse A is given, A inverse also given, but here we have an unknown value. We have to find that value. Here it is well-known formula. AB equal to BA equal to I. B is called inverse of A. Means you can write like this also. B equal to A inverse. A into A inverse. B equal to A inverse. A inverse into A equal to I. A into A inverse equal to I. Or A inverse into A equal to I. Now simply multiply these two and equate it to I. No need to multiplicate each and every element, but here in third column we have unknown value. Okay, that's why here A into A inverse equal to I. Just multiply here. Just try to understand here I means it is 3 by 3 matrix 1 0 0 0 1 0 0 0 1. A into A transpose nothing but here by multiplying with the first row, first column, here we are getting the element. First row, second. First row, second, here. First row, third column, here only. In third column, we have unknown value. That's why just multiplying the first row with the third column and write down here and equating to 0. Why? Because these two matrices are equal. Therefore, its corresponding elements also equal. Just multiply first row with third column and equating to 0, you will get the answer. Here by multiplying 1 into 2, 2 plus minus 1 into alpha.
Sir,
Yes.
sir, but it is given A inverse is equal to 1 by 10 of that matrix.
Yes, just taking after that we by 10 only. Later we can write by 10.
Okay, sir. Thank you, sir.
Okay. Here I am writing it again. It is not clear. What is the gap is very less. That's why I am writing here. A into here, A into A inverse equal to I. That implies A means 1 minus 1, 1, 2, 1 minus 3. No need to write these matrices also. It is a time-based process. But are at learning stage. That's why I'm writing all the steps in detail. But Later, you can reduce those steps also. Directly means by doing direct step. Now multiply first row and first row with third column and equating to zero, you get the answer. That is here first row, first column, multiply first row, second column here. Now first row, third column. By 10 is also there. By 10. 1 into 2, 2. Minus 1 into alpha, minus alpha. 1 into 3, 3. Remaining elements are not required for us. That is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Now just by equating this element to u 0, you get the answer. Tell me alpha value. Alpha value is it 5? Yes, answer is 5. Very good. Ragini, Navas, very good. Is it 5? Yes, it is 5. Answer is 5 only. It is actually 2004 question. Now 2 minus alpha plus 3 by 10 equal to 0. That is 5 minus alpha equal to 0, alpha equal to 5. Next problem. It is previous IIT question. If A equal to matrix minus 1, 3 by 2, minus 1 by 2, 1 by 2, then I plus A square and so on up to infinity equal to dash. First option 1, 1 minus 3, 4. Second option 2 by 7 into 1 minus 3 minus 1, 4. Third option 2 by 7 into 1, 3 minus 1, 4. Fourth option undefined. Now it is infinity terms of GP. A plus AR plus AR square and so on up to A into R power n minus 1. It is called a GP series. It is called a GP series. In GP series, it is called nth term A into R power n minus 1, and sum of n terms equal to A into R power n minus 1 by R minus 1 if R is greater than 1. A into 1 minus R power n by 1 minus R if R is less than 1. Now sum of infinity terms equal to, that is possible only when R less than 1. It is possible only when R less than 1. If R less than 1, here n tends to infinity. If n tends to infinity, R is less than 1. Less than 1 rise to n. Less than 1 rise to infinity is 0. Less than 1 rise to infinity is 0. Therefore, it becomes 0. Therefore, we are getting A by 1 minus R formula. Very good. Now, A by 1 minus R. R is called common ratio. Now, here question is I plus A square and so on up to infinity. It is equal to A. A means first term. But in matrices, first term is I. I by 1. 1 means it is belongs to natural real numbers. But here in formula, if you apply this formula here, you should write not I, not 1. It is I. I minus common ratio is R means second term by first term, or third term by second term. That is called common ratio. I plus A square and so on up to infinity equal to, by applying A by 1 minus R formula. A means first term, their first term is I. I by 1, not 1 minus R, it is I by matrices, we are writing I minus A only. In matrices, instead of real number, we are writing I. Now it is equal to I by 1, I minus A. I means, now you can write this as, now take this term to the numerator. Now it becomes inverse, I minus A whole inverse. That is equal to I into I minus A whole inverse. Okay? Now, I into any matrix equal to I into A equal to A only. Therefore, I into this is also equal to this matrix only. First simplify. First to simplify it. Now it is I. What is I minus A? I minus A. I means unit matrix. Well, it is 2 by 2 matrix 1, 0, 0, 1 minus A. A means minus 1, 3 by 2. Minus 1 by 2, 1 by 2. Now I minus A becomes 1 minus of 1 minus 1, that is 2. 0 minus 3 by 2 minus 3 by 2. 0 minus of minus 1 by 2 1 by 2. 1 minus 1 by 2 1 by 2. It is I minus A. Therefore, it is equal to 2 minus 3 by 2, 1 by 2, again 1 by 2, whole inverse. Now, another formula 2 by 2 matrix inverse formula. Is it over? Now, formula for A inverse, that is A, B, C, D, whole inverse equal to 2 by 2 matrix inverse equal to A inverse equal to adjoint A by that A formula. Adjoint A by that A. Here determinant that is in denominator, its determinant is AD minus BC. Its adjoint A means just we have direct shortcut. Just interchange these two. Means here we have A, here we have D, A, D interchange. For the other two elements, multiplying with minus. That is formula for A inverse. Now, by applying that formula, we get 2 minus 3 by 2, 1 by 2, 1 by 2, whole inverse equal to 1 by AD minus BC, 2 into 1 by 2, 1 minus BC, product of these two, minus 1 by 2 into minus 3 by 2, minus 3 by 4, plus 3 by 4 into, just interchange these and multiplying other two elements by minus 1. It is plus 3 by 2, it is minus 1 by 2. Determinant is
Sir, C bit, sir. Answer.
answer is
C.
C. Very good. Answer is C only. Now it is 4 by 7 into 1 by 2, 3 by 2, minus 1 by 2, 2. Now answer is D. Just multiply 2 by 7. 4 can be written 2 into 2. Now multiply with 2. Multiply this matrix by 2. Means 2 into 1 by 2. 1, 3, minus 1, 4. That is the answer. Very good. Very good. It is previous IIT question. We are at one of the most important question. Generally, for mains point of view, you should be familiar with all previous IIT questions compulsory. Why? Because every year, almost every year, we are expecting minimum 2-3 questions from previous IIT papers. That's why you should concentrate on each and every IIT question paper. Be alert. If you are strong in all previous IIT questions, you will get 100% NIT seat. Of course, you may have a lot of chances to get IIT seat also. Is it over? Next question. If A equal to 2, 1 minus 4 minus 2, then I plus 2A plus 3A square and so on up to infinity equal to dash. Actually, it is belongs to arithmetical geometric series progression. Arithmetical geometric progression. Why? Because here first terms are in GP, common difference is ratio, and second terms are in GP. First terms 1, 2, 3, 4 are in AP. I, A square, A cube are in GP. That's why it is arithmetical geometric progression. We have some method for this, but that method is not so applicable here. Why? Because it is created question. Look here. First find A square value. What is A square? Why? Because except the first two in from third term onwards, in every term we have A square value. First find what is A square. A square means A into E. A means A into E. 2, 1 minus 4 minus 2. 2, 1 minus 4 minus. Just multiply it. Yes, it is a null matrix. 2 into 2, 4 minus 4. 2 into 1, 2 minus 2 minus 8 plus 8 minus 4 plus 4. It is a null matrix. Now, the given expression becomes I plus 2A plus, it is null matrix, A square is null matrix here. We have A cube term. A cube means A square into something. A square is null matrix. Null matrix into any matrix becomes null matrix only. Yes, here all are null matrices except this result. That's why this is that expression is also equal to I plus 2A. Whereas I means
Sir, 5 2 minus 3 minus 8 3.
yes. Final answer is 5 2 minus 8 minus 3. This is the final answer. Yes, correct. 2 into A multiplying A by 2. 2 into 2 4. 2 minus 8 minus 4. Yes, correct. Now go for another problem. If a square minus 3a plus 2I equal to O, then first option a is singular, second option a inverse equal to 3I plus a by 2, third option a inverse equal to I minus 3a by 2, fourth option a inverse equal to 3I minus a by 2. Very good. Sai Durga Prasad. Answer is D. Very simple question. For this type of equation, it is called matrix equation. To get inverse, multiply by A inverse on both sides. Multiplied by A inverse on both sides. A inverse into A square minus 3A plus 2I. That is equal to A inverse on right hand side, A inverse into O. A inverse into O means O only, non matrix. Here A inverse into A equal to I, remember that. Now this can be written as A into A inverse into A into A. A into A inverse, A square minus 3 into A inverse into A plus 2 into A inverse into I equal to, yes, D is the correct answer. A inverse into A equal to IA minus 3 I plus 2. A inverse into I equal to A inverse only. IA equal to sorry, A minus 3I equal to A minus 3I plus 2 into A inverse equal to, now 2 into A inverse equal to, taking these two terms to the right hand side, that is 3I minus A. Now A inverse equal to 3I minus A upon 2. That is the answer. Very good. D is the correct answer. Now, I'm giving one important concept to you that is based on eigenvalues and eigenvectors. Eigenvalues and eigenvectors. Actually, that is in engineering course. In the first year engineering, we have the concept eigenvalues and eigenvectors. By using that concept, we can be able to do some problems. Now I am giving that concept to you. By using that, we have one theorem also. Just try to remember, otherwise, it is in engineering first year. Okay. Now, just write down its concept. That is also that is called Cayley-Hamilton theorem. Cayley-Hamilton theorem. Square matrix A, capital A, satisfies its characteristic equation. That is important. Characteristic equation. That is called zeta of A minus lambda I equal to 0. That is, generally that equation is of the form C naught into A raised to n. Here A is a square matrix plus C1 A power n minus 1. Generally that is in the form of this form equal to C n minus 1 A plus C n I equal to 0. Just write down, I will explain that. Here lambda is called eigen value of A matrix A. Eigen value of A. It is also called either eigenvalue or characteristic root. Characteristic root of A. Lambda is called eigenvalue of A or characteristic equation, characteristic root of A.
So what is C?
C. Just a C is C naught, C1, C2 or any constants.
Okay.
Any real numbers.
Okay.
Actually, it is in engineering first year. I'm not ready to discuss the in-depth level of this part. I think it is not useful to you. Just I'm giving how to do. our problems. That's all. By using this concept, we can able to get the answer within a few steps. That's why I am introducing. Eigenvalues, that is, you are asking the definition of eigenvalue. Okay. Yeah. Actually, here statement theorem is let A be n by n square matrix. N by n square matrix. Here, if otherwise not on that, so the meaning of eigenvector or eigenvalue. Eigenvalue. Okay, first note of this. I will explain that concept also. What is eigenvalue? What is eigenvector? I will explain. Nawaz is asking that question. Okay, that concept. Of course. First, just note of this. Here, generally in our questions, matrix A is given. Matrix A is given. Just find this equation. A minus lambda I equal to 0. Get of A minus lambda I equal to 0. By applying this formula, you will get an equation in matrix form. Instead of lambda, okay, first write. Is it over? Now, here, no, let A, capital A, be n by n matrix, means n by n square matrix. N by n square matrix. If there exists, a non-zero vector x, a non-zero vector x, and a scalar lambda such that a into x equal to lambda into x, a into x equal to lambda into x. Here generally if A is a square matrix, x is any variable matrix, here lambda is any scalar quantity. Okay, x is a non-zero vector. That is a matrix, of course, vector nothing but it is a matrix here. And lambda is a scalar quantity. No doubt at all, this equation is exists. You can write this equation. Here, lambda is called. Hold on. Then if you can write into this form, then lambda is called eigenvalue of capital A. If you can write into this form, no doubt at all, here lambda is called eigenvalue of A, and x is called eigenvector of A. Eigenvector of A. You can write this equation as a minus lambda into x equal to a minus lambda into x equal to 0. But here the problem is here it is a matrix, but it is a number. That is not possible. That's why here you should write I only. To write it to matrix form, you should write that real number into I always. Lambda I. Why? Because it is a matrix. But if it is a real number, matrix with subtraction is not possible between matrix and scalar quantity. That's why now it becomes matrix. Lambda I becomes matrix. Now it is a matrix, it is a matrix. Now it is possible. This is called homogeneous equal to 0 form system of equations. Now it is homogeneous system of equations. Suppose it having this system is called homogeneous system of equations. Its system has non-trivial solution. It has non-trivial solution if and only if its det equal to 0. Of course, data of this means data of this into data of this. Here I x not equal to x is a non-zero vector. By taking modulus sign, it is non-zero. That's why by taking modulus, it must be 0. By taking modulus, sorry, by taking determinant, it becomes 0. But it is a non-zero quantity, therefore it must be 0. Therefore, we are getting a minus data of a minus lambda equal to 0. It is called characteristic equation. It is called characteristic equation. Okay, just note down. Don't worry. That's why I'm telling. If you remember this only formula, you can be able to do the problem. But you are asking, sir, what is eigenvalue, what is eigenvector, when it is applicable. That's why I'm not trying to involve into this part. Just we require only some formula. Just that is derived from test means engineering test book. That's why if you apply it directly by taking this formula, it will be over. But you are asking in-depth level questions, sir, what is, why we are taking, what is meant by eigenvalue. Then it is applicable. That's why I am explaining. That's why the mind is going. Just what I am telling is, just try to remember this equation only. It is only this formula is useful to us. That's all. Okay, now I am just entering into numbers. Let's. It is in engineering first year syllabus. Okay, for this, on this we have some theorems also. That's why I am not interested to enter into that part. For example, A is given. Example, A matrix is given. Square matrix is given. Now, its characteristic equation is try to remember this last step. Its characteristic equation is deta of lambda equal to 0. That's all. Here, what is A minus lambda I? Deta of A minus lambda. A means 1, 4. Of course, here also we can write direct step, but you can't able to understand it. After one or two step, after one or two problems, you can able to write direct step. Lambda into I means 2 by 2 matrix. Lambda I means lambda into I means 1 0 0 1. Means it becomes lambda 0 0 lambda. Okay, lambda 0 0 lambda equal to 0. Actually, no need to write this step also. Directly you can write 1 minus lambda, 4 minus 0, 3 minus 0, 2 minus lambda. It is not characteristic equation. Simply leave these two elements for principal diagonals, write down minus lambda, etc. Over it will be over. Why are you worrying about this equation? Okay. Now its characteristic values, eigenvalues are by expanding this 1 minus lambda into 2 minus lambda minus 12 equal to 0. Now 2 minus lambda minus 2 lambda plus lambda square minus 12 equal to 0. Now it is lambda square minus 3 lambda minus 10 equal to 0. It is called characteristic equation. For this matrix, instead of lambda, if you put A, capital A, that is called matrix equation directly. For the that matrix, this is exist. You can write like this also, but it is a matrix equation. Here lambda is called eigenvalue of eigenvalue of A. Leave it, just leave it. Just how to write this step first. Try to write this step directly and put lambda equal to A directly. You get this step. Then from this you can find the A value, A inverse also. Of course, it is 2 by 2. You have direct formula A inverse. You have direct A inverse formula for 2 by 2 matrix. But for 3 by 3 matrix, how to find A inverse? Of course, we have a very lengthy method. I think this is the easiest method for you. Now for this matrix, you can find A inverse also. How? Multiply with A inverse. Now A inverse into A square. A inverse into A means A. Oh, sorry. A inverse. A square can be written as A into A. You can write like that. Minus 3 into A inverse into A. Minus 10 into A inverse into I equal to A inverse 1. O into A inverse O. Now it is IA minus 3. A inverse into I means I minus 10 into A inverse equal to 0. O. Now IA equal to A minus 3I equal to 10 into A inverse. Now A inverse equal to A minus 3I by 10. Of course, you can find A inverse like this also, like this method also. Means like this also. You can derive. Just know now, I will explain another problem by using the same concept. But if you practice it well, it becomes very easy. Later you will observe it. Just know now, just know now. It is most important concept in our IIT syllabus. By using this concept, you can be able to do very lengthy problems also by using this concept within a very less time. I will explain one or two problems on this. Is it over? Next problem. Now, IIT 2005 question. If A equal to 1000110 minus 24 and I equal to 100010001 and A inverse equal to 1 by 6 of A square plus CA plus DI, then C and D are first option minus 6 minus 11, 6 11 minus 6 11, 6 minus 11. If you apply it, try to get the result by using regular methods. If you try for regular method, it is very lengthy. Why? Because first it is given matrix is 3 by 3 matrix. For this to find A inverse means it is not a simple method. Again here, if you are getting A inverse, then that is also not sufficient for us. You have to find A square, then CA, then find CA, then find DI, then by adding this and equating to this. That is not a simple method. But by using characteristic equation, you can reduce some steps. Of course, it is also not very short method. Now here, for A matrix, square matrix A, find characteristic equation. How characteristic equation is delta of A minus lambda equal to 0. That is delta of, for diagonal elements, write down minus lambda, etc. For remaining same means for this element 1 minus lambda, remaining same 0, 0, 0, 1 minus lambda, 1, 0, minus 2, 4 minus lambda. Any confusion? Yes. Now just simply by expanding this, you will get the equation in terms of matrix form. Then multiplying with A inverse, directly you will get the answer. Very simple method. Of course, not so simple. Now by expanding this, we are getting 1 minus lambda into this into this minus 1 minus lambda into 4 minus lambda minus, it is minus means plus 2 equal to 0. Now, by simplifying this, 1 minus lambda whole square into 4 minus lambda plus 2 into 1 minus lambda equal to 0. Now that becomes 1 minus lambda whole square is 1 plus lambda square minus 2 lambda into 4 minus lambda plus 2 minus 2 lambda equal to 0. Now 4 plus 2 6 minus lambda, okay, carry on. 4 minus lambda plus 4 lambda square minus lambda cube minus 8 lambda plus 2 lambda square plus 2 minus 2 lambda equal to 0, that is minus lambda cube plus 6 lambda square minus 8 lambda minus 2 lambda minus 10 lambda minus lambda minus 11 lambda 4 plus 2 6 equal to 0. Now multiplying with minus sign, you will get lambda cube. Otherwise, now put lambda equal to a. You will get that is not really Hamilton theorem. By putting lambda equal to a, it is minus a cube plus 6a square minus 11a. But it is constant only. For constant, write down 6i equal to. Then multiply with a inverse. Directly you will get this form. Multiply with a inverse. Multiply with a inverse minus a inverse into a I. For understanding, if you okay, now minus a inverse into minus a cube plus 6a square minus 11a plus 6i equal to a inverse into 1a inverse into a I means minus a square is remaining. A square into I again a square. Now here plus 6 into a inverse into a equal to I into 1a is remaining minus 11 into a inverse I plus 6 into I, see I into a inverse only equal to now a inverse equal to 6 into a inverse equal to a square minus 6a plus 11i now a inverse equal to 1 by 6 into a square minus 6a plus 11. Now you can compare with this result with this. If you practice it number of times, it will you will get the answer within 2 minutes. Of course, actually, if you go for regular method, it is very lengthy and also boring. Now, directly by comparing with this C equal to minus 6, C equal to minus 6, D equal to 11, D equal to 11, that is the answer. Answer is third option. Of course, it is somewhat lengthy, but no other alternative for this. Next question. If A equal to 1, 2, 3, 4, then A power 4 minus 5A cube minus A square minus 4A minus I equal to dash. First option O, second option I, third option A, fourth option A plus I. For this problem also, first find characteristic equation, that is A minus lambda equal to 0, that is that of for principal, diagonal, divided minus lambda, etc. means 1 minus lambda remaining as it is equal to 0. Expand it. 1 minus lambda into 4 minus lambda minus 6 equal to 0. Now 4 minus lambda minus 4 lambda plus lambda square minus 6 equal to 0. That is lambda square minus 5 lambda minus 2 equal to 0. Instead of lambda, you can write a. Now it becomes a square minus 5a minus 2I equal to O. Any doubt? Any doubt in this step? Yes. Now, here a square equal to 5a plus 2I. Okay? Now, multiply with a again. Why? Because we require a power 4 I and also a cube also. Multiply with a, we get a into a square, a cube equal to 5a into a square plus 2 into I into a equal to, sorry. Now again multiply with a, again multiply with a on both sides, a power 4 equal to 5a cube plus 2a square. Now just observe it, observe this expression. Now taking this term to the left hand side, now a power 4 minus a 5a cube, it will match with this portion, observe it. Equal to 2a square, but here we require only minus a square equal to 2a square. Now adding, here minus a square is required. Adding minus a square on both sides. Now it is a power 4 minus 5a cube minus a square equal to, it is a square only, 2a square minus a square, a square. Again a square can be written as, a square means that is 5a plus 2I. Only this question is coincide with this. Again, minus 4a minus I is required. It is a power 4 minus 5a cube minus a square. Adding minus 4a minus I on both sides. Now we get a power 4 minus 5a cube minus a square minus 4a minus I, that is also equal to 5a plus 2I minus 4a minus. Correct. Now final answer is 4a minus 5a minus 4a a plus I. Answer is both of it. It is one of the alternative method. Remember that. Otherwise, directly you can find by finding a power 4, a cube, a square, and put here. You get the answer. But that is comparative. That is, I think, lengthy. Of course, if you feel it easy, you can continue that method also. Next previous ID question. It is a new concept only, we alert. It is not in CBSE syllabus. It is only for IIT and also useful to you in JEE mains. Is it over? Next problem. It is multiple correct answer question. Be ready, be alert. Previous IIT question. If A equal to -4, -3, -3, 1, 0, 1, 4, 4, 3, then A inverse equal to dash. First option, A transpose. Second, A. Third, A square plus A minus I. You require homework? You want homework? Okay, do it homework otherwise. Okay? But it is multiple correct question, answer type question. Multiple correct answer type. Here also, first I am giving small hint for you. Just by finding characteristic equation and by putting lambda equal to A, directly you will get the matrix equation. Then by multiplying with the A inverse on both sides, you will get the answer. But check each and every option. Why? Because it is multiple correct answer type question, previous IIT question. If you are getting only one answer, that is not sufficient for you. You will check each and every option. Be alert. Okay? Okay, next model. I'm giving one more homework question. If A equal to 2, 2, 1, 1, 3, 1, 1, 2, 2, then A cube minus 7A square plus 10A equal to dash. First option 5I plus A. Second option 5I minus A. Third option A minus 5I. Fourth option 6I. By using same concept. Next question. Evaluate data of cos of A minus B, cos of A minus Q, cos of A minus R, cos of B minus P, cos of B minus Q, cos of B minus R, cos of C minus P, cos of C minus Q, cos of C minus R. It is IIT 94 question. Now, look here. Try to expand this determinant. It is cos of A minus B formula. Cos A cos B plus sin A sin B. It is cos A cos Q plus sin A sin Q. cos A cos R plus sin A sin R, cos B cos B plus sin B sin B, cos B cos Q plus sin B sin Q, cos B cos R plus sin B sin R, cos C cos B plus sin C sin B, cos C cos Q plus sin C sin Q, cos C cos R plus sin C sin R. Now you can write this determinant as the product of two determinants. Can you write the given determinant into the product of two determinants? Of course, here it has 3 by 3. Na? You can write 0 into 0 also. Every time write down add 0 into 0, 0 into 0, etc. Write down. Then for every element write down plus 0 into 0. Now, just by observing the first element, that is the result of, that is the product of two determinant, no doubt enough. Now, that is, in first determinant we have cos A, cos B. Next, sin A, sin B. Next, 0, 0. Can you write like that? Now go for second element. Cos A, cos Q. By multiplying first row with second column, you will get this result. Cos A, cos Q plus sin A, sin Q, 0 into 0. Next step. By multiplying first row with the third column, you will get this element. Cos A, cos R, sin A, sin R, 0.
Sir, answer 0, sir.
Yes, very good. Here, the third row having all are 0. Like that, here also, you will get, of course, simply by here, any row having all 0, determinant is 0. 0 into anything, 0. Otherwise, here also we have, it is the cos B, cos C, it is the full, means full form of the, wait. Yes, cos, sin C. Actually, it is the complete form of the determinants. But here, simple concept is, it is the product of two determinants. Now it's the determinant value is 0. It is also 0. Final answer is 0. It seems to be very difficult level problem, but it is simple. but you should write this step. This is most important step in this problem. Like this, for this type of problems, means in matrices we have some problems of this type. How to write the given determinant into the product of two determinants. We have around 5 or 6 important problems of this type. Now I have very less type questions of this type. Later I will provide. I will provide later. Any confusion? Only Nawaz is responding very good. The remaining are not responding very well.
Sir, I am
Observe.
safe.
Okay. Okay. Yes, only Nawaz is responding. What about
Sir,
remaining?
Sir, Soumya Chaudhary is also responding, sir.
Okay, 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 very good. Next question, next question. IIT JEE 2000 question. Evaluate data of sin theta, cos theta, sin 2 theta, sin of theta plus 2 pi by 3, cos of theta plus 2 pi by 3, sin of 2 theta plus 4 pi by 3, sin of theta minus 2 pi by 3, cos of theta minus 2 pi by 3, sin of 2 theta minus 4 pi by 3. Try. These are challenging problems only. You are responding, that's why I am giving some difficult problems also. If you feel very difficult, I will skip this type of questions. Okay? Now here in trigonometry, we have in trigonometric transformations, we have some formula. Sin of a plus b plus sin of a minus b equal to 2 sin a cos b. Otherwise, expanding sin of a plus b and sin of a minus b, and by adding these two directly, you will get this step. Similarly, cos of A plus B plus cos of A minus B equal to 2 cos A cos B. Here, these two formulae are applicable while solving this problem. Here, instead of C3 means R3.
Sir, can you give options, sir?
It is subject to type question. That's why don't
Subject to.
expect options for this.
Okay, sir.
In previously before 2005 we have the option means subject to type questions only. It is belongs to the type of question. If you want to make it objective type, I will make it if you require.
No, sir.
Okay. I'm giving small hint for this. Instead of R3, write down R2 plus R3. R2 plus R3. Write down here only. Directly. You'll get clear idea about after getting this step, after applying this operation, you'll get clear idea about the answer. Try. Sai Durga Prasad, you are saying that it is, you said that it is 0. Okay? Try again, try.